Okay, so this is our virtual order assistant. It's going to be a AI-driven customer service agent that uses an avatar in order to enhance the customer service experience in multiple workplaces. The idea is for it to be versatile, so it can be used. For example, it can be used as a library assistant. It can be used at a drive-through. It can be used at a gate, but the idea is to minimize labor and cost while also improving customer service quality and immersion. Yeah. Okay, so as far as the project summary goes, the idea is to develop a multi-purpose AI assistant with an AI avatar in order to enhance customer service while reducing labor and cost. Generally, this technology already exists, but it's limited, and our goal is to build on what already exists and improve in the areas of weakness of those technologies. Some of those areas of weakness include just natural conversation, whether or not it feels like you're talking to a real person or just a robot. Certain disabilities that cause speech impediments, the inability to hear or speak or see, all can affect your ability to use that technology. So, our combination of um, verbal and visual, what's the word I'm looking for? Verbal and visual presentation, I guess, is how we're going to solve that problem and attempt to cater to people with disabilities of all types. And then you also have language barriers. We intend to make a multilingual system. And not only will it be able to handle language barriers, but it will also be able to handle any sort of slang, any sort of thick accents, things that make it particularly difficult to understand natural language. Okay, next slide, please. Okay, so when we're defining our project, the first thing we needed to do was figure out key challenges and technologies, challenges that we're going to have to overcome, and technologies that we're going to use to do that. The biggest challenges we identified were colloquialisms and slang, or language that doesn't necessarily have its exact dictionary definition. So when recognizing natural language, it's very difficult for a machine to understand meaning behind a word other than its dictionary definition meaning. So that's going to be a challenge for us to tackle. Latency constraints. The idea is for our system to be seamless. You want to have, when you're having a conversation with a person, typically there's not much latency. You're talking with the person, they respond pretty immediately. So that's going to be something we have to tackle, especially in low bandwidth areas. And then multi-turn dialogues. A lot of times when you're speaking with an AI, it tends to lose track of the topic of conversation the longer the conversation continues. So we're going to have to find a way to address that and make sure that it retains the topic of conversation throughout the entire thing. And the technologies we're going to use to approach this problem is we're going to use a high resolution display unit so that our avatar is pictured and is easy to see. You can see all its hand gestures, facial expressions, and that'll really help with the overall immersion of the customer service experience. Same thing with cameras, microphones, and speakers. A big part of that is using directional sound technology in order to make sure that it's not picking up conversations from anyone other than the using party. Natural language processing, input output, text to speech, speech to text, its ability to detect language and respond appropriately. And then our interactive AI avatar, its ability to use the right visual cues, whether that's hand gestures, facial expressions, actually a moving mouth that looks like it's saying the words it's saying, all of that included, just is designed to contribute to the overall experience and make it as immersive as possible. Okay, now the main problem we're trying to solve is inadequacy in modern customer service. And there's a lot of areas that can be improved upon because most customer service is handled by humans, and humans have all sorts of different flaws, and you're always going to get a different experience depending on where you go. We aim to address these issues and create a generalized solution that can be used in any work environment. And a lot of these issues that we aim to fix are, as we discussed before, various disabilities, language barriers, and the ability to process natural language. all while simultaneously reducing overall costs and labor. So we're going to improve customer service while also decreasing the cost to provide said customer service. And we're going to do so seamlessly. Hopefully the input and output will be as seamless as possible, so it feels like you're having a real conversation. And that will make it as if you're speaking to a real person, but you don't actually have to take on the cost of paying for a real person to deliver that customer service.
So this UML diagram illustrates the overall system flow for our virtual ordering assistant. It begins with the user appearing on screen, where the camera detects and recognizes them. This then triggers an initial greeting from the avatar. The diagram then transitions into an interactive loop where the user places an order, and each item is processed and sent to the back end, allowing the user to add multiple items incrementally, and they show up on the display as it's happening, so they can see their order in real time. And once the user signals that the order is complete, the system finalizes and submits the order, which is then acknowledged and confirmed by the back end. Next slide. So now we're going to go into the internal logic flow of the back-end system and how the avatar interacts with that. So it starts with the waiting for user detection. It passively monitors the presence using a camera or a sensor, and once the system detects motion or presence of a user, it transitions to the next phase where once the user is detected, it greets the user. The avatar becomes visible on screen, and it verbally prompts for a user to make an order, and it then transitions into listening for input. The avatar leverages speech to text and natural language processes to interpret what the user is saying, and that's when it then parses for the intent and classifying the input. The user input is routed through a parsing intent component that performs speech recognition, intent detection, and classification, like if it's an order related question, or if it's like a clarification related question, or even if it's ambiguous and unknown. The system will have to parse the intent for all three of those possible use cases, and then it has to respond appropriately. Based on the intent, the system has to transition into response, which can be, if it inputs a question, it has to retrieve the relevant information and answer that, or if the input is an order, it has to transition into the order mode. And the order mode is handled where it logs the item into its current order, like a cart, and it confirms that the order is added. So if the user says, I want a coffee, it confirms verbally that adding a coffee, and it prompts as well if they would like to add anything else. And this loop continues until the user gives a termination signal like that's all, or I'd like to check out. And that's when the session ends, where it closes out the order phase, it displays the total price, and it displays a message like your order has been placed and will be processed. Next slide. This diagram details how the flow of the user instructions, updates, and interacts within the ordering system. It begins when the user makes a request, like ordering a drink, removing an item, or asking about contents of a menu item, which is first captured and interpreted by the front end, so it gets the intent, and it puts the input into the back end, which is then structured into an intent processor, which once the intent is classified, like adding an item, removing an item, or asking about certain items, it's routed to the back end where the appropriate logic is triggered. So for order modification, the back end communicates with the order manager, which handles the current state of the user's order. This allows for real-time addition into the user's cart and can remove items, add items, modify items. And if a user asks about a specific menu item, the backend calls a menu service, which returns detailed information about ingredients, preparation, and this response is passed through the backend into the UI. The beauty of doing it in this modular component format is that we can change the use case into virtually anything. So it expands on different knowledge bases, so it can be for restaurants, for healthcare, and whatnot. Next slide.
So the virtual order assistant will have several features, including a facially animated digital multilingual voice recognition and speech output. And it's also going to be completely touchless, so no need to touch a screen or do anything like that. It's going to use directional speakers, which allow for a very private service. You won't have to have anyone else hear anything that you're saying. And most importantly, it'll be designed to connect easily with current systems like ordering platforms at kiosks and stuff like that. So the Avatar front end will run on Unity, and the back end will use Python, which is Google's speech API, and ChatGPT for natural language processing, with the MongoDB for storage interactions. And the hardware is going to include a microphone, motion tracking camera, digital speakers, and all backend logic is going to run on AWS EC2 to support real-time communications. So as we've already done, we defined our project scope, defined all the requirements that we're going to have to do, and then Uzi created all of the UML diagrams, everything like that. And then we go into our prototyping and everything in the future, which we're going to integrate all the components that we've talked about previously. And lastly, we'll refine the budget to allow for a cost-effective approach to our solution. So a virtual order assistant will improve service speed and reduce labor strain. It will be especially helpful for users with disabilities or language barriers, and in the future we plan to add motion detection, AR guidance, and offline capabilities using edge computing to improve reliability and personalization.
So now we're going to talk about things in the context of how we plan to actually implement our product. So as we know, our goal is to build and design the virtual order assistant. We want to make sure that it is low cost, it's scalable, and that it utilizes our AI-driven concept to create automated customer service in customer service-driven businesses like drive-thrus and other similar environments. So our top priorities when thinking about implementing this are making sure that we have low-cost hardware. We have a modular software stack where we know that there's scalability in the future for easy reconfiguration for applications in different industries like Uzi mentioned. And also we want to make sure that there will be real-time performance because we need our model and our product to respond real-time to customers when they're interacting with the user interface. Next slide. So in terms of implementing, we've started to do product research into the hardware and software that we wish to use in order to develop our product. So in terms of hardware, our plan is to use a Jetson Nano or Raspberry Pi 4B single board computer in order to establish the computational power that we've determined is necessary for our product. And in order to provide the best user interface for our users, we want at least a 1080p display monitor to show our avatar in real time and to offer the best user experience. We also plan to use the directional ultrasonic speakers and microphone arrays in order to facilitate the private and accurate voice exchange, especially in those difficult environments like noisy drive-thrus or places that are in public. We plan to use high-definition cameras and driveway vehicle sensors in order to detect when the user has reached the product, especially if we're doing that in the scenario of a drive-thru. And then we also want to make sure that our product is durable and will last and have good longevity, so we plan on having some type of weatherproofing case in order to protect the product. So in terms of software, in order to implement all of the things that we've discussed, building on what Jacob went over, we're going to use OpenAI Whisper and Azure speech-to-text and text-to-speech in order for the natural language processing. We plan to use either HeyGen or Unity in order to develop the actual AI avatar that the user will interact with. And then in terms of the backend, we're going to use Flask and Node.js Express or OpenCV with the YOLO V8. And then in order for data analytics, since we will be using a lot of Amazon Web Services, like discussed for the architecture, we plan to use Firebase or AWS Dynamo Database in order for the data and analytics. Next slide. So just to again reiterate, that our plan is to have a modular system with layers that operate separate of each other, but then are able to communicate with each other. So we'll have the input layer that will collect the video and voice and environmental data from the user. And then we plan to have the AI engine layer that is going to go ahead and process all of the inputs with the natural language processing, speech to text, and text to speech. We also plan on having a motion recognition to provide the most pleasurable experience to the users, because we do want our product to mimic a real human interaction. And then our response layer is going to be where we'll develop the avatar, the text prompts, and the directional audio, and what we show back to the user. And then the integration layer is going to be the layer where we're able to scale our product to interact with the external systems, like the POS system, the library checkouts, or any other type of customer service based environment where we plan to implement this. And then in order to communicate between the layers, we plan on using RESTful APIs and WebSockets. We want to make sure that there is real-time and structured data flow, because we do need real-time responses given this product would be with users in real time. Next slide. So then one of the biggest and most important parts of implementation, since this is a product that is going to be upfront with users, it would include a lot of testing in order to make sure that the product operates correctly. So there are different areas of focus for testing that we want to focus on in order to establish everything that we've discussed. So we want to make sure that we have unit testing in order to validate our core components, which would include the natural language processing, the speech to text, and making sure that our product is actually able to interact with the input from the user. And then we want to make sure that we also include integration testing, system testing, environmental testing, latency, and security and usability. So all of those other areas of focus have to do with the previously mentioned applications that we plan to have for the model. And then example test cases, ones that we've come up with that we know we want to test for our product, include voice input and making sure that the product can actually process the input information that is given from the user. We also want to make sure that our system is able to communicate with the external systems that would be needed to implement them with the specific businesses. So making sure that the orders are sent, that they're received, and that they're confirmed, and that there's good communication between those external systems. And then we also want to make sure that our AI model is trained in order to adequately provide information and understand the information that the user is providing based on the system. So for the example of the drive-through application, that would include like menu inquiry. And then in order to complete this testing, we're going to use products like Postman, PyTest, Wirestack, and Azure Monitor. So Postman is going to deal with the API stimulations and making sure that the backend communication as well. The PyTest and Unitest is going to be used for the backend automation to make sure that the logic is sound. And then Wirestack is going to be used for the network diagnostics so that we can make sure that we can deal with the real-time responses. And then the same thing would be for Azure Monitor and Firebase Logs.
And this is our organizational chart for Group 3. We're guided on this project by both our sponsor/advisor, Dr. Yepes, and our senior design professor, Professor Zhuang. The group is split into two major teams. One is focused on the avatar development and AI machine learning aspects of the project, and the other is focused on the backend and testing. I will be on the natural language processing and speech to text, text to speech integration. Anthony's going to be on the avatar development in Unity and Unreal. Jacob's going to be on the computer vision and directional audio integration. That team is going to be pretty much in charge of making sure the avatar interacts in real time within the specifications of the project. And then Uzi and Lyric are going to be in charge of backend development and API integration and logging, testing, and ensuring that our product, passes all of those unit cases that she mentioned earlier. And then next slide, please. And then these are all of our references regarding the product, any API technologies and hardware, software that we may be using within this project.